Ladies and gentlemen, welcome back to a new unit. We are continuing our study of electric circuits. We're in a new unit, technically, called DC circuits, but we are still basically talking about electric circuits. So the last unit and this unit fit really well together. Okay, we're going to start off with a look at electrical meters. Okay, electrical meters are the way that we measure the quantities that we're after in the circuit. You know that the primary quantities that we're after are voltage, current, and resistance, right? The three quantities in Ohm's law. So let's take a closer look at how we can measure each of those. Okay, each meter has its own name depending on what you're measuring. So if you're measuring voltage, it's going to be the voltmeter, and you see a picture here of two older types of voltmeters. Okay, current's going to be measured with an ammeter, as in measuring amps. Okay, and the same kind of naming goes for resistance. If you're gonna measure resistance, it's going to be measuring ohms, right? So an ohm meter. Okay. Now the ones pictured here are all kind of old school analog meters. All right. Today we tend to use digital meters, and in fact the most common meter you're going to see is the one that I've got pictured here, which is called a digital multimeter. Okay. And it's called a multimeter because it measures multiple quantities. In fact, it measures all three of the ones that we want: voltage, current, and resistance. Let's take a closer look at the dial. If you look at the dial, you see that there's a section there for voltage. Okay, and actually two types of voltage. There's a DC voltage, right, for like a battery. Okay, let me get to the right pen here. So here's a DC voltage. It's like kind of like a straight line. And then this is AC voltage, which you're not going to use. And right underneath is amps, okay, and then over here is ohms. So depending on where we turn this dial, right, we can measure each of those three quantities. Okay, so you're going to be using a multimeter soon in class, and we want you to be familiar with how to use it and how to hook it into a circuit. Let's use this multimeter first of all as a voltmeter. Okay. All right, so when using the multimeter as a voltmeter, right, we want to have the dial point it to the correct section. So we want to point it here, right, in the DC volt section. So you want to pay attention to that. And what I want to show you is how to hook the voltmeter into the circuit. Okay, and it's helpful to remember here the coal car analogy. So what I'm going to do is pause the video for a minute, and I'm going to put some numbers in here, and then draw the appropriate coal mine analogy. Okay. All right, you can see here I picked a 10-volt battery, okay, 5-ohm resistor. And so if you do Ohm's law, that's going to be 2 amps of current. Okay, 10 volts divided by 5 ohms is 2 amps. That's why you see the coal cars all multiplied by 2. Remember, current is not consumed as you go around the circuit. That's why all the multipliers are the same. Okay, the coal cars themselves are not consumed, only the energy in them, right? So there's only one power plant here, and that is the light bulb, okay? So there's only one place where the voltage changes, right? Where there's a potential difference. Remember, voltage and potential difference are synonyms. Okay, so we have to go to that location in the circuit, and basically, if you want to see how much just think about it in the coal car analogy. If you want to see how much the coal amount changes, you're going to need to know how much coal there was before and how much coal there is after. Okay, so what that's going to mean is the following. We're basically going to take the multimeter, okay, we're going to take this red one here, and we're going to put it before the light bulb, right, before the power plant, okay? And basically what that test lead's doing is it's sampling, like, okay, how much coal's in the coal car before we go into the power plant, right? And then you take your black test lead and you hook it up to the other side like that, okay? And you say, okay, how much coal is in the coal car after it comes out of the power plant, and what the multimeter will display. Okay, I'm going to use a rectangular box here. So what that voltmeter, or the multimeter in this case, is going to display is the difference between 10 and 0, right? So what you're going to see on the display is you're going to see 10. Okay, it's 10 volts, right? Because all of the coal, all of the voltage from the battery is used at the light bulb. So now this is sort of what it would actually look like, you know, on the tabletop, right? When you actually hook the multimeter in, okay. But there is a circuit diagram way of drawing it. All right. The circuit diagram symbol for the voltmeter looks like this. Okay, it's actually just a circle with the letter V in it. Okay, and then you've got, you know, a wire coming off each end like that. So the way that we're going to draw the circuit diagram method to draw what you've seen here, okay, is I'm going to go ahead and erase this now. Erase not the whole thing, but just this part here, okay, the actual drawing multimeter part, okay, and I'm going to replace it with the circuit diagram version. All right, so now I'm going to draw in for you what this would look like, sort of circuit diagram style, okay, so it would look like this, all right, like that, okay. Now, that's called connecting the voltmeter in parallel because you create a separate path for current to flow, right? Because there's the one path through here, right, through the light bulb like that, okay? And then there's a separate path through the voltmeter. But remember, when we measure something, we don't want the thing that we're using to measure to affect our measurement, or at least we want to minimize that effect, right? So what we're going to do in this case is we're going to make the resistance of the voltmeter really high, okay? And that way, very little current from the circuit will actually go into the voltmeter. Just enough to get a voltage, okay, but not enough to really affect the overall circuit, okay? So to summarize, if we want to use a multimeter as a voltmeter, we hook it in parallel with the part of the circuit that we want to measure, okay? And a voltmeter, in order to get its proper measurement, is going to have a very high resistance. Okay, let's go to the next page. We're going to move on to using the multimeter as an ammeter. Okay, so if you look at the multimeter dial, we're going to have to turn the dial to be over here in the ammeter section, right? So somewhere like that. And we're actually also going to have to move this red test lead. We're going to have to move it from here to this other red socket. Okay, and you're going to see that red socket has a label. It's a little obscured here, but it has a label with an A. Okay, for amps. By the way, you see on the ammeter different choices, right? There's a couple of different places here, okay? In other words, you could click the ammeter here, or here, or here, and this is true for the volt section too. And that's all depends on like how many volts are coming in, okay? So it kind of scales itself. Like if you have a max of 2 volts or a max of 5 milliamps, it allows you to scale it appropriately, and you'll see that when you use it in class. But what I want to show you now is how to connect the ammeter into the circuit. You're going to see that the ammeter hooks in quite differently. Okay, since the ammeter is measuring current and it's measuring the actual flow, what we're going to want to do is we're going to actually have to physically break open the circuit. Okay, so what I would have to do here is like disconnect the wire and actually make space for the ammeter. And then what I would do is I would hook the red lead in. Okay, I'd hook the red lead in right here. I'd hook the black lead in on the other side like so. Okay, and then that ammeter, okay, is going to show me the current flowing through the circuit, okay? So what we're basically doing is we're making the current that's flowing through the circuit also flow through the ammeter, right? So that it's all one path, right? Notice that there's not two paths like with the voltmeter, okay? In other words, the current that's flowing in the circuit is also the current flowing in the ammeter, okay? And you're going to get a digital readout here, some number, okay, and the units will be amps, okay? So notice that the way it's hooked in is different, okay? In fact, we use a different word. We say that it's hooked in series with the circuit, okay? In other words, we don't create a new path like with the voltmeter, okay, which is called parallel. We keep the same path. We break that path open and make space for the ammeter, okay? So because we don't want our measuring device to affect our measurement, this time, because the ammeter is part of the flow and there's only one path, we actually have to make the ammeter have a very low resistance, right? So ammeters are designed to have a very low resistance, okay, so as not to affect the flow. One way to think about how an ammeter works is this little drawing here, okay, which is supposed to be a water wheel. If we go back to our water analogy of a circuit, you think of the wires as carrying water, okay? The more current there is, the more this water wheel would spin, okay? So if you think about how you want to design that water wheel, you want to make it really light, right? You wouldn't want it to be heavy, creating a lot of resistance and therefore affecting the flow. You'd want to make it really light so that the flow is not affected by the meter, okay, by the water wheel. All right, let me show you what this is going to look like circuit diagram fashion. Okay, so let me take those things away there. The ammeter has its own symbol, okay? And that symbol is similar to the voltmeter, okay? It is basically just a circle, okay? That would not be a circle. It's basically just a circle, okay, with lines coming out. Okay, so this right here is an ammeter. Okay, so the circuit diagram symbol for an ammeter is just a circle with an A and two lines coming out. All right, finally we have the ohm meter. Okay, the ohm meter, you're going to have to click to the appropriate part of the multimeter, right? It's going to be this section right here. Okay, and we don't use the ohm meter quite as much. The main thing here, okay, is that you're not going to connect the ohm meter, okay, directly into the circuit. So the only thing here that has any resistance is the light bulb, right? So what we would have to do is we would actually have to physically take the light bulb out, okay? We'd actually have to take the light bulb out. And then once the light bulb's out of the circuit, right, so let's just get rid of the circuit, okay? We'll just get rid of the circuit. Once the light bulb's out, okay, now we can measure its resistance separately. And again, in this case, you actually end up hooking it in parallel. Okay, so the red lead goes there, and the black lead goes on the other side. Okay, so that's actually there's only one path here. So if you just want to measure the resistance of any component, you actually have to take it out of the circuit, right? Whether it be the battery or the light bulb or the actual resistor. Okay, and then you just hook it up to the circuit. And the multimeter uses its own battery to create a little current through there, and then uses that to display the proper resistance here on